Assalamualaikum and kata good morning ke? It's morning right now when I'm recording this. Okay, I'm not feeling very well, so that's why my voice is like this. But I have to record this topic anyway. So let's have a lecture on chapter 3. Okay, so we have completed chapter 2 on how to solve the second and higher order differential equation by using certain method lah. Okay, by using the method of undetermined coefficient and variation of parameters. Now we will look at the third chapter, okay, where in the third chapter here we will focus on Laplace transform. So what is Laplace transform is all about? Okay, what you will learn in this chapter is this process. You know the objective in chapter 1 and chapter 2, right? So the main objective that we have covered before is whenever you are given differential equation, okay, like ay double prime plus by prime plus cy equal to fx, or you are given ay prime plus by equal to fx, for example. Okay, in chapter 1 and chapter 2, you are given the differential equation in this form, and the main objective of your solution is to find what is the y. Yx or yt, depends on yx. What is the y? So basically the whole objective in our course dalam DE ni is when you are given this, how to get this. So that is the general objective for this course. So in chapter 1, you have this first order and then you want to find what is the y. In chapter 2, you are given second order, then you want to find the y, or the third order or the fourth order. Okay, now in chapter 3, our objective is still the same. Okay, but what we will learn here is if you are given DE, okay, which is in the t or x domain. Okay, when you are given DE, in this chapter, you will learn how to use the Laplace transform so that you can write this DE into S domain. Kalau tadi dia YT kan, YX kan, bila kita guna Laplace transform, it's going to be in the form of S domain. So S domain tu, we will solve the equation algebraically. So we are going to solve the S domain algebraically, and then we are going to use the inverse. Okay, inverse Laplace transform and get the final solution in T form. Okay, you are given DE. Kalau before this, in chapter 1, you are given DE and then you use separable, exact, Bernoulli, linear to find YT, right? And then all those steps needs you to do all the integration, right? So in chapter 2, you learn how to use method of undetermined coefficient, variation of parameter, okay, to solve the differential equation. Okay, this part. But in chapter 3, it is slightly different. We will still use the we will still solve the differential equation, but what we do is to do the transformation first. We transform the equation into Laplace transform from T domain, and it will become the S domain. Okay, and then we do the solution here. After we do the solution, then we have to do the inverse because the original equation is in the form of T domain. So basically, this is what we will learn in this chapter lah. Okay, now how the chapter will go is something like this. Okay, first we learn how to do the transformation first from T to S domain. And after that, we will learn how to do the inverse Laplace transform so that we can get from S to T domain. And lastly, only we learn how to solve the DE algebraically here. So basically, those are the steps that we will learn. Okay, now that is the introduction to the Laplace transform. Let's move to the content here. So in Laplace transform, first there will be the definition of Laplace transform. Okay, definition of Laplace transform. Then you will learn how to do the Laplace transform properties. Okay, so once we learn the Laplace transform properties, there are 3 types of properties here. Okay, after that, you will learn how to use the Laplace transform to solve the unit step function and delta direct function. Okay, so this part is how to do the Laplace transformation. Okay, how to transform from T to S domain. The second part of this chapter is how to do the inverse Laplace transform. And the last part only we learn how to solve. To solve here means to find y lah from dy dt or d2y dt2. Okay, now let's move to the definition of Laplace transform. Okay, Laplace transform is given by this formula. Okay, this formula here is the specific formula for Laplace transform. Okay, we have Laplace transform. Originally, C is a function in T. Okay, but once we do the Laplace transform, now we write the equation in the form of Fs. Originally, small f, right, and T domain, but now it become big F and S domain. That is Laplace transformation. The formula for Laplace transformation is given like this. Okay, integration of E negative ST and FT. We got this FT from the equation that we have. So this basic formula is also available in the list of table. Okay, Laplace table. If you look at this Laplace table, on the top of the table, you are given the definition of Laplace transform. Okay, so this is important because in the test or in the exam, sometimes you were asked to use the definition to find Laplace transformation. So this is what you need to use. Okay, you have to use the formula here. Okay, how to use the formula? Let's have a look at this example. You are given, use the definition, okay, to find Fs. When the Ft given to you is a, where A is a constant. Okay, A is a constant. Constant here means it can be any number lah. It can be 5, 10, 100, 3, 7. Okay, it can be any number, just a constant. So when it is a constant here, by using the definition of Laplace transform, okay, the formula is like this. Laplace transform for A, okay, is given by the integration from 0 to infinity E negative ST FT. So FT here is given by A. Okay. So this is how we use the formula. Okay, the A here, we put it here. Since a is a constant and the integration is done with respect to t here, so we can take out the constant out from the integral like this. So we will have only e negative st dt. And notice that we have the symbol of infinity here. So this is an improper integral. Therefore, our equation and solution should be something like this. Or if you don't want to get confused between the t here, the t here, we can substitute with another symbol. I can use the big T, okay? So now we do the integration. We have a, where the limit for the t here is going up to infinity, and then e negative st is given by negative s from 0 to t. Okay, so that is the integration for the exponent. You will get the exponent itself, but then you have to differentiate the negative st here. That will give you negative s. So when we substitute here, we need to substitute the interval. So what we will have here is e negative s big T divided by negative s, and minus with e negative s times 0 divided by negative s, like this. So e negative s0 is given by 0. No, not 0, sorry. It's 1. E negative kosong. E kuasa kosong kan? Sama dengan 1. So the solution will be A. The limit t tends to infinity, e negative st over negative s plus 1 over s. How do I got plus? This one and this one. That will give me a positive value. Okay, now, how about this one? What is the value that we should get for e negative st, where the big T here tends to infinity? I already, I think in the first or second chapter, I think we already see the value, right? So this is supposed to be e negative st equal to 1 over e st. So when t tends to infinity, what will happen here is we will get 1 over e with the power of infinity. So e with the power of infinity is a very big number, right? Okay, then we will get 1 over infinity, which is equivalent to 0 lah. Because infinity is a very big number. So 1 divided by trillion, zillion, or any other number, right? So we will get 0.000000, which is close to 0 lah, basically. Okay, so this can be 0 for our answer. So therefore, the value that we get here is only this 0 plus 1 over s, right? So the Laplace transformation for a constant is given by a over s, like this. So this is what you'll see in the Laplace table here. Okay, you are given a constant k, and the Laplace transformation for this constant k is given by k over s. Okay, so how do we get k over s? Just by using the definition like this. Okay, so that is how